Assalamualaikum and hi. We are a group from class CS112-1B and our group will present about techniques of differentiation for our assessment 2, subject calculus 1, called subject MAT 183. And this is our group members. Meaning of differentiation. Differentiation is the process of finding the derivative of a function which provides information about the slope of the function at any given point. It is a fundamental concept in calculus dealing with the rate at which quantity changes and allows for the determination of how fast one quantity changes in relation to another. Its application includes finding the instantaneous velocity of a moving object or the maximum or minimum value of a function. Next, techniques of differentiation. First, we have constant rule. The derivative of constant is 0. Second, power rule. We use power rule to differentiate power of x. Third, chain rule. Chain rule used when a function is inside another function. Fourth, product rule. This applied when two functions are multiplied. Fifth, quotient rule. Quotient rule applied when one function is divided by another. 6. Derivatives of trigonometry. It is for differentiating sine, cosine, tangent, and other trigonometric functions. 7. Derivatives of logarithmic functions. We use this for differentiating logarithmic functions. Last but not least, derivatives of exponential functions. These functions for differentiating exponential functions.
Okay, for the next question, question number 2. Find dy over dx for the following function. A, y minus 9e power of x times x minus 3. So from the question given, we can see that 9e power of x is multiplied by tan x minus 3. That means we need to use product rule. So the product rule is dy over dx equal to u v prime plus vu prime. So we need to decide which one is the u and the v. So the u is 9e power of x and the v is tan x minus 3. So the u prime means the differentiate of u. So u prime is 9e power of x. For the v prime, tan x minus 3, when we differentiate, it will become secant squared. So vu prime equal to secant squared x minus 3. So then we just replace the v and u, so that it will become 9e power of x secant squared x minus 3 plus tan x minus 3 9e power of x. And then we just rearrange the number and remove the unnecessary bracket, so we can move 9e power of x to the front. It will become 9e power of x secant squared x minus 3 plus 9e power of x tan x minus 3. And then we can factorize because we have the same number 9e power of x. We can factorize it and just move it to the front, so it will become 9e power of x secant x minus 3 plus tan x minus 3. So that's the final answer. Okay, for 2b, based on this question, we will be using quotient rule because quotient rule happen when there is a division on the number. So for example, this question, y equal to x squared plus 1 divided by sin x. So we will be using dy over dx equal to vu prime minus uv prime over v squared. So the u is x squared plus 1. So when we differentiate the number, it will become 2x. That's the u prime. For the v, it was sin x. When we differentiate sin x, it will become cos x. So then we just replace the u and v. So it will become sin x 2x minus x squared plus 1 cos x over, in the bracket, sin x square. and then we just multiply everything, so it will become 2x sin x minus x squared plus 1 cos x over sine squared x. That's the final answer.
For question 3, we need to find dy over dx using implicate differentiation. The original equation is ln y plus sin square bracket x square plus e power of y equal to 5xy. The first step, we need to differentiate ln y. Since y is a function of x, the derivative become 1 over y multiply y prime. Now, I differentiate the sin square term using two substitution. I let the outer function be u and the inside function be v. So I define u equal to sin v and v equal to x square plus e power of y. This means sin square bracket x square plus e power of y become u square. Next, I differentiate the outer function u square become d over dx u square equal to 2u multiply du over dx. Next, I differentiate u equal to sin v become du over dx equal to cos v multiply dv over dx. Next, I differentiate v equal to x square plus e power of y become dv over dx equal to 2x plus e power of y multiply y prime. So the derivative of sin square bracket x square plus e power of y is 2u multiply cos v multiply dv over dx. Then I substitute u and v back to the equation become 2 multiply sin bracket x square plus e power of y multiply cos x square plus e power of y multiply 2x plus e power of y multiply y prime. Now I differentiate the right hand side 5xy. Again, I will use u and v. Let u equal to 5x and v equal to y. Then u prime equal to y and v prime equal to y prime. Now I apply the product rule, become d over dx bracket u multiply v equal to u prime v plus uv prime become 5y plus 5x y prime. Now I put all the differentiate part together, become 1 over y multiply y prime plus 2 sin bracket x square plus e power of y cos bracket x square plus e power of y bracket 2x plus e power of y prime equal to 5y plus 5x y prime. Next, I expand the middle term, and this give 4x since bracket x square plus e power of y cos x square plus e power of y plus 2e power of y sin bracket x square plus e power of y cos x square plus e power of y prime. So now the equation become 1 over y multiply y prime plus 4x sin x square plus e power of y cos x square plus e power of y prime equal to 5y plus 5x y prime. Now I gather all the y prime term together, or dy over dx together, become 1 power over y prime plus 2e power of y since bracket x square plus e power of y cos bracket x square plus e power of y prime plus 5xy prime equal to 5 5y minus 4x since bracket x square plus e power of y cos x square plus e power of y. Next, I factor out y prime for the left side. Y prime multiply 1 over y plus 2e power of y sin bracket square plus e power of y cos bracket square plus e power of y minus 5x equal to 5y minus 4x sin x square plus e power of y cos x square plus e power of y. Now I divide both sides by the bracket, and dy over dx equal to 5y minus 4x sin x square plus e power of y cos bracket x square plus e power of y divided by 1 over y plus 2e power of y sin x square plus e power of y cos bracket x square plus e power of y minus 5x. And that is the final answer.
So for the last question, use linear approximation to estimate the value of 8.02 square minus cube root of 8.02. So the value for f(x) is 8.02 square minus cube root 8.02. So differentiate, we should replace the value with x is equal to x square minus cube root x. After that, differentiate the value of f(x) that has been replaced with x become f prime x is equal to 2x minus 1 over 3 x power of 2 divided by 3. For that, we should identify which is the given value or chosen value. So the given value is that has been given in question. It is 8.02. So the chosen value is the integer that near with the value. It is 8. By using the formula delta x equal to x minus x naught, we can insert the value. It is 8.02 minus 8. So we got 0.02. 0.02 is the delta x. Well, with all the information, use this formula f in bracket x naught plus delta x close bracket equal to f x naught plus f prime x naught multiplied with delta x. So substitute the value into formula, so it's become x squared minus cube root 8 plus 2 multiply 8 minus 1 divided by 3 times 8 power of 2 over 3 multiply with 0.02. So the final answer is equal to 62.32. So that's all from us. Thank you.